Okay, today we're going to be talking about arrays. So we'll spend about 10 or 15 minutes and just go through high-level arrays, what I expect you to know moving into the semester, and we'll look at a little bit of sample code. We'll look at the code that I provided in the content section of D2L. So after this conversation, if you guys have any questions, please let me know as I can help you work through arrays and any questions you might have. Bottom line, with arrays, what I expect, to take away from all this conversation today is that you can define an array, you understand how to control the size of the array, you can assign values to the elements of the array, you can access those values, and then you can use an array as an argument to a function, and you understand at least a little bit about that pass by value and pass by reference. So we'll take a look at that today. Again, if you have questions, you don't understand something, let me know so that I can help you work through that. So what is an array? Well, it's a structure of related data items, okay? So when we declare an array, we declare a type. So if we say we have an integer array or a char array or a float array, that means that every value and every element in that array will be of the same type. So they're all related. Oftentimes with the array as well, the data is related some way, in some fashion, right? If we're writing a simple program and we're inputting test scores, then usually we have an array that stores test scores. So not only will those be integer values or maybe a float or a double, but it'll also be related in that they're all test scores. It's not as important to understand right now, but it will be critical later on in the semester that you understand that when we declare an array, we have consecutive memory locations. Okay, when we start working with pointers and malloc, you'll need to understand how the memory works, and that an array, the way arrays work, why we can iterate over them the way we do, is because it's all a consecutive block of memory. Overall, the format. Okay, so we define an array, and we'll look at some code here in just a little bit. So you shouldn't have any, we should be able to. I'll show you some definite examples of doing that. We look at an array, then we declare an array, we define the size when we declare the array. When we do that, one thing you need to remember, you need to understand, is that every array starts at index 0, and then it goes until whatever size you define. So if we look at this graphic here, you probably saw this in 150, or well, at least there was a chance you saw it in 150, and we have a 12-element array. It starts at 0. The first index is 0. So it's the 0th element. It's the first element, but it has an index of 0. And we go to an index of 11. Index 11, but that's actually the 12th element of the array. So if I said, what is, let's see, the value of the 5th element? Then you'd actually look at index 4, 1543, right? That's the 5th element, but it has an index of 4 because we start at 0. Arrays always start at 0. So keep that in mind because it's very simple. It's very common to have off by 1 errors because you start at 1, especially when we're creating loops and we want to iterate over every value or every element of an array. A couple of things that I'm going to throw at you that you probably didn't talk about, and this isn't something that I am expecting you to use necessarily. I'm going to use them. They're good practice. They're good programming practice, and so I want you to at least be able to recognize them when you see them in my code. First is symbolic constant. And we define those using the define keyword. So if you look here at this third bullet, this is how we would define a symbolic constant. And all it is essentially it's a shortcut. We're saying that I define the symbolic constant size and I gave it a value of 10. That way, when my program's compiled, everywhere that I use size, it gets replaced with the value 10. So when we have when we're using the same value over and over and over again, let's say we have a program we're declaring 15 arrays and they all have a size 10. Instead of typing in 10 in our declaration, we can use the symbolic constant. That way, if we need to change that, let's say that those array size needs to change from 10 to 20, we change the symbolic constant, and that's the only one place we touch it. We don't have to go into the program and modify every single instance of using that. So I'll show you an example of that. Feel free to use them if you want. If you don't want to, that's fine as well. But I will use them, so you need to be able to at least recognize them in my code. The next one is the size underscore t type. I will use it. If you use it, it's up to you. The book uses them. And what's important to know about this is it's an unsigned integer type. So the difference between a signed and an unsigned integer is that an unsigned integer cannot have a negative value. When we're working with arrays, this is important because an array can never have a negative size and it can never have a negative index. So when we're using a value as our increment variable to increment over elements of an array, we want to make sure it can never be negative because our array can never have a negative length or never have a negative index. Alright, so we'll look at defining and initializing. I'm going to skip over those slides because we're just going to get into some examples here. there's a couple different ways you can do it. You need to determine which way works best for you, which way you think is the most efficient. So when we look at defining an array, just like defining a variable, we start with the type, we'd give it the name of the array, and then we use the opening and closing square brackets. Okay, what we put inside of there then is the size of the array. So when we define an array, we have to define the size at the same time. Until we talk about malloc, when we define an array, we have to define the size at the same time. So putting the value 10 in here means that I'm defining array 1 to be an integer array of 10 elements. Now, oftentimes when we declare the array, we want to initialize the values at the same time. Okay, this is shorthand if you use the squarely bracket on the right-hand side of an assignment operation. Okay, all three of these statements are assignment operations. Assignment operation means that we're using one single equal sign to assign the value on the right hand to something on the left-hand side. So here, if we use this curly bracket, we've declared a 10-element array, and we've initialized all 10 elements with a value. This first value corresponds with element 1, or index 0, and then it just goes on until the end of the array. Second example, we have array 2. It's a 20-element array. We use an initialization list, but we don't have 20 values. So what happens with this array then is it will put value 0 in index 0, or this first value, so value 0 into the first element, 1 into the second, 2 into the third, fourth, fifth, and sixth, and then the rest of it will initialize all values to 0. Okay, just like our variables, it's very important that we initialize all our values to 0, because when we get a variable, we assign a variable, we declare an array, we have allocated for us memory in the system, and until we clear out that memory by assigning something to it, null or 0, if we try to access that memory location, we haven't zeroed it out, we could get unexpected results. We could get a large negative or positive number, and it could impact our programs in a very significant and undesirable way. The other thing we can do with this example is we can declare an array and just do in parentheses a 0, and that'll initialize every single element of the array regardless of the size to a value of 0. So desirable to do this regardless on how you actually do it. Finally, you can see here that we can declare an array and we don't need to put the size in the declaration. What happens then is we need to provide an initialization list, and the array will take the size based off of the number of initializers. So array 3, we haven't explicitly defined a size, but there's 1, 2, 3, 4, 5 values in that initialization list, so it'll be a 5-element array. Okay, just to go back here, common programming error. Remember, the 0th index is the same as the first element, so it's very easy to get off by 1, and we know that with arrays, okay, if you have a 10-element array, there's nothing stopping us from trying to access an 11th or a 12th or a 13th element. If it's only a 10-element array, those elements don't exist, and so now you've charted off into territory where that memory that's been allocated for that array doesn't belong to you, and that will cause your program to crash. So when we're writing arrays, you're working with arrays, and your program is crashing, you don't know why, then you need to go and take a look at how are you iterating over that array, making sure that you're not going off of the end of the array. If it's a 10-element array, then your loop needs to go from 0 to 9. It needs to go from 0 to 1 less the size of the array. So just make sure that you're not going out of the bounds of the array. There's nothing in C right now that prevents that from happening. Okay, so let's take a look. I'm going to exit my VM. Hopefully, take a look at some code. Okay, this is the file that I have uploaded to D2L, and you'll see that I've kind of provided a solution for you already. And so if you want to work on this like we did with the functions review, then just delete the functions and use the to-dos to help define how you want to make it. So don't really study these, don't really look at them, just delete them or make a copy of this file and remove them and then try to solve it. This one though, you have the solution, so unfortunately you kind of have to work backwards if you want that experience. With this, these are also some good functions just to have, because this is stuff that we'll probably do throughout the semester to just help us create some programs. So we'll look at here in this first section, these are all my function prototypes. So we define the prototypes before main, and then this is my flow for structuring a C program, and then below main is where I define my custom functions. Okay. So function prototype, just to review, we define it just like the function, except that it ends with a semicolon, and we implement the function somewhere else. As far as this program overall, let's take a look at the main function itself. Okay, we're generating random numbers. So I did miss an include. It's not vital that you have this include in here, because if you try to reference a function from a library that you didn't include, the compiler will just try to make some assumptions for you. So it doesn't stop this program from working correctly, but it is important that I do want the time function from the time header file. So it's just better practice for me to define those to make sure I'm telling the compiler exactly where to look for these files, for these functions. Alright, so generating random numbers. Remember, we need to seed the random number generator for any random number generation that we do. This is all you need to do. So if you don't understand it, that's perfectly fine, but make sure you copy this line of code. The next thing we do, we declare an array. Okay, just like declaring a variable, we have to give it a type, we have to give it a name, and then we define the size. Okay, once we do that, we assign it or initialize those values. So here's an array called random number. Its size is going to be based off this symbolic constant. So we'll go up and look at that in just a sec. And every single element in this array will be initialized to 0. Here is where I define the symbolic constant. Okay, so we use the hashtag with the word define. This is the symbol I want to use, and this is the value that's going to be replaced by. Okay, so size will have a value of 5. You can see with my text editor, if I highlight size, I use it in 1, 2, 3, 4, 5 different places. So if I need to change that, okay, symbolic constant, this program is compiled, size is replaced with 5. So I have an array of size 5. I have a loop that goes from 0 to less than 5. I call these functions, we'll look at that in just a second, with passing the array itself and then the size of 5. Let's say I want to change this program. If I didn't have the symbolic constant, I would have to go through here. Instead of having size, I would have a number there, and I'd have to change every single instance of those numbers. But with the symbolic constant, I don't have to do that. See, I can change that symbolic constant, and now everything in my program went from being a 5 to a 6. The program will work, there'll be no errors, and that just made my life a little bit easier. So that's why I use symbolic constants. Look at the top of the program. If you ever see something like this, typically you're going to write these in all uppercase. I think maybe you actually have to, check the top of the program and just see. So defined our array. Next thing we do, we have int I. So I said that we should use size underscore t. We can do that here. I is a counter. I is being used to access the indexes of that array. So we want to make sure that it's going to be a positive number. Start our loop, for loop. Initialize I to 0. Remember, arrays start at an index of 0. So when we want to iterate over the array and we need to start at that first element, then our counter has to start at a 0 value. I is less than size. Okay, we always want to go less than the size of the array. The size is 5, so I'll go tell us less than 5. That means I is 4. So from 0 to 4, that's 5 iterations. 5 elements, 5 iterations. And then our increment counter plus plus, I plus plus, we just want to go one by one. Alright, first thing we do, now we're in this loop, each iteration, we access the element, we access that index based on the value of I, and we assign it a new value. Okay, so as you access each individual element of an array, you can think of it just like its own variable. Right? So element with this first iteration, I is equal to 0, so this will access the 0th element, and we can think of it like a variable, an integer variable. So we want to assign a value to it. Generate random number. I'm going to scroll all the way down here. We'll look at that custom function. Return type is int. There's the name. It has one argument, and that is the scale, an integer value here. And just like the program that we looked at for functions, we do rand mod by the scale. Okay, so if scale has a value of 100, then we know that the possible values that we can return for this function will be 0 to 99. Alright, so that's all that's doing. We're just coming up with a way to fill this array full of random stuff and allow us to manipulate it a little bit later. If you wanted to skip this random number generation stuff and just create an initialization list with values, that's fine too. It doesn't matter. We're just using this to just fill that array with something. Alright, the next thing we'll do is we'll display the array. So we'll look at that function in a second. All that does is prints off every single value. Then we're going to look at modifying the array, and then we're going to display the array again. Alright, so in order to do that, let's look at that display array function. Alright, you can see that it does not have a return. Well, its return type is void, so it's not returning any values. And we have two arguments. One is how we declare an array as an argument, and then the second is just simply an integer value. Okay, so when we declare an integer, just a little bit larger, when we declare an array as an argument, it's very similar to how we define it. Okay, we have to say what is the type of the array. So in this case, it's going to be an integer. What is the name of the argument that we want to have? In this case, I just said A. And then we use the square brackets, but we do not put any information in here. We do not define the size. We do not define anything. This is all we need. Okay, there's the concept of pass by reference and pass by value, and that is something that is very important. And I'm going to assume that you talked about that in 150. And so arrays are always pass by reference, and that means that this is really just giving us the memory address of the array, so that when we modify the contents of that array, we're modifying it globally. We're pointing to that same place in memory, and so if we modify it in a function, then that's modified it for the program. Okay. The second argument is a pass by value, so that means that we create a copy of this for the function. So when this function is called, we pass it some value, a copy of that value is made, and then it's used in the function. So if we change that value in the function, it doesn't have any impact on the same variable that we use to call it. Okay, so pass by value means that this won't be changed. Pass by reference means that if this is changed in the function, it's changed globally for the program. So we'll look at display array. Okay, it's right here. Okay, function prototype, exact same as the implementation, except we get rid of the semicolon, we add the curly brackets. Now we declare a for loop, okay, int, we can use size underscore t, doesn't matter. We can declare that, declare a loop, we start at 0, we go to less than size, and we do I++. Alright, in this case, we could actually use the symbolic constant here if we wanted to. I could say size instead of using the argument size, and I could get rid of that. But the reason we don't, change that back, the reason we don't is that we want this function to be dynamic. We're going to have multiple arrays in our programs. In this program we don't. We have one array with one size, gives us a very contrived example. But let's say that we have a much larger program, and we're going to want to display the array, but every array is going to have a different size. We're going to have multiple symbolic constants, we're going to have multiple arrays of varying sizes. So that way, this function will work no matter what size of the array. The problem, why we pass the size as a second argument, is because we don't know the size of this array. That's why we're requiring our user to pass the value as the second argument. That way we use the value of size to set up our loop. We'll say we're going to start at 0, we're going to go into I is less than size, so we'll have the exact number of iterations that there are elements in the array. And then from here, all we do is we simply increment, iterate over every single element, and we print off. Okay, we say this is the element I'm on, and this is the value. Okay, so we access those individual elements using the array name, the square brackets, and then the index that we want to access. So the index in this case being represented by our counter I. Alright, how do we call that? Okay, display array. First argument is an array. Okay, we've already declared an array, so all we have to do is provide the name of the array. We don't have to provide square brackets with any particular index. We just need to provide the name of the array. The second value just needs to be an integer value. In this case, because the program is set up and all these functions are being called, on the same array, we can use our symbolic constant. So when this program gets compiled, this size will be replaced with 5. Right? So what we'll do then is we'll call display array, we'll fill it with random numbers, we'll print off all those values, then we'll call modified array. Alright, modified array, if you look at the function prototype, you can see it's very similar to display array. Return type is void, 2 arguments, an array, and then the size. What's different inside modified array is that we're modifying the array. Okay, I just want to prove the concept of pass by reference. The array is passed by reference. So even though this argument has a different name, we're passing a reference to this array. We define random number here, we pass it by reference in this function call here, so random number becomes a reference in this function. That reference is represented by the argument A. So when we modify that array, when we access these individual elements and set a new value equal to 0, what you'll see is back in main, we print we have the random numbers. We modify, we've now set all those elements to 0 inside the modify array function. This just prints a new line to give us some visual separation, and now we print the array again. And because we modified the array here, when we call this display array, you'll see that we have in fact modified the contents of this, the random number array. So let's take a second and we'll take a look at that program. I'm gonna see here. I'm gonna compile this again just to make sure that I didn't make any changes. See, I did. Oh yeah. All right. So this error, okay, %d expects argument of type int, but argument 2 has type size underscore t. You're gonna run into that if you decide to use size underscore t. And because I don't remember the solution, I think I just need to change the format specifier to li, and it's a long integer. Let's see if that works. Yep, that works. So you just know that you might run into that. Okay, so what happened is I used format specifier d in this function. I changed this from int to size underscore t. So %d, because I'm printing that counter there, printing that variable there, that no longer works. You need a different format specifier. So li is the format specifier that you need to use, or at least it's the one I need to use on my system. So you might run into some issues if you start using size underscore t. That should be the solution for most of them, but just know that you just might have to deal with it. Google is your friend, or of course send me an email and I'll help you out. So arrays review, and let's run the program. All right, so there's our output. First call the display array. You see we print all those values, those random values that we generated between 0 and 99. Then we called modify array, in which inside that function we've set every element's value equal to 0. We print a new line, and then we display the array again. So these two display array function calls are done inside of main, and you can see that in fact, because that's a pass by reference, we've changed the values from these randomly generated ones to all zeros. All right, and the last thing, and I don't actually call this one in the main method, but just to take a look at it quick, is the computed average. Okay, so something that's common to do is once we have a bunch of values in an array, we probably want to sum them up to calculate an average. Okay, so in order to do that, we'll probably want this function to return, and right now we have it set up as a return type of integer, and then its arguments are the same. We have the array and then the size. So if we look at the computed average function, you'll see, okay, same loop. Right, we're using the same exact structure over and over again to iterate over an array. We declare an integer variable I for our counter. We use a for loop. I is less than size. Make sure we start at 0 and then increment our counter by 1 after every iteration. In order to get the sum of the elements, then we have a sum variable. Everything's an integer type, so we initialize that variable equal to 0, and then we add to it each time through. Okay, so sum plus equals the value of the element represented by index at index I. So that is getting us the sum. When we're done, we return sum divided by size. Okay, and that would be the average. So if you wanted to compute the sum, you would just get rid of this division by size. All right. So on a return statement like this, when we do a return, there's this order of precedence, right? We have to figure out sum divided by size, the value of that, then we return the value from there. So that is how the computed average works. Okay, so that's everything on the arrays. Again, this is basically what I'm expecting you to be able to know. You can declare an array, you can populate or initialize the values, you can access the elements of the array to set a new value, you can access the element of the array to use the value. In this case, we use it for printf. Maybe we need to pass it to another function at some point in time. And you also know how to define a function that accepts an array as an argument. So again, I'm assuming everybody went through this. I can't guarantee that, so that's why we're going through this review. If this is unfamiliar with you, please take some time, work on the practice labs, work on this assignment here. This isn't an assignment; it's not due. There's not going to be a Dropbox. But work through this code, read the corresponding chapter in the book, and then always let me know if you have questions. We can talk it through. Otherwise, that's it. And the next lab, so the lab will be open here shortly, and you can work on that. And again, simply let me know if you have questions. All right, thanks.